Okay, so this is our review for Chapter 2, which is test number 2. So we're going to talk about quadratic equations, putting in the standard form, plotting them, long division, complex numbers, synthetic division. Let's see what else we can do here. Let's just look at this test that I had given before, and I see I have inverse functions, but we covered that in the first chapter. So anyway, we'll cover everything that I plan to have on this test. So the first thing we're going to do is we're going to be given a quadratic equation in not standard form, but in just the normal form. So you're going to have x squared plus, let's say, 8x minus 2. Okay, I think that'll work out. And what I'm looking for is putting in standard form, calculate the x and y intercepts, the vertex, and the axis of symmetry, and then sketch the actual function. So let's go ahead and put it in standard form first. So to do that, we're going to do completing the square. So you do that by taking the second order part and the first order part and moving the constant over out of the way. Then you take the coefficient in front of the x, divide by 2, and square it. So that's going to be 4 squared, which is 16. So what we'll do is we'll add 16, and we will subtract 16. And then we can take the first 3 terms and collapse those into a perfect square. And the number used is 4 here. Whatever this number is, it's not always 4, but squared minus 18. Okay, now as far as finding the let's see, the first thing is the x-intercepts. So to find the x-intercepts, you always set y equal to 0, or f of x, same thing. So you get 0 is equal to x plus 4 squared minus 18. So you can then solve for x. So you'd add 18 to both sides. Then you would switch the sides, just so I have the x on the left-hand side. Then you take the square root of both sides, so that'll give you x plus 4 equals plus or minus the square root of 18. And then you subtract 4 from both sides, so you get negative 4 plus or minus the square root of 18, which is going to be negative 4 plus or minus 3 times the square root of 2. So I've just said 18 is 9 times 2, square root of 9 is 3. And what we'll actually do is we'll come up with the decimal numbers, so because we're going to have to plot those on a graph. So I'm trying to find my calculator. So let me just pause for a second. Okay, so we're going to pause. We're going to pause. We're done. Okay, so let's. So what is 3 times the square root of 2? 3 times the square root of 2 is 4.24. So this is negative 4 plus or minus 4.24. So you can see if I have the plus part, I'll get 0.24. And if I take the negative, I'll have negative 8.24. So those are my x-intercepts. The y-intercept, you set x equal to 0. And in that case, you go back to the original form instead of doing it here, just easier. You get the same answer either way, but so you say what is y or what is f of x when x equals 0? Well, the answer is negative 2. It's just the constant part. So that's the y-intercept. Okay, what else do we need to do here? Vertex. So the vertex are the, remember from standard form, you have x minus h squared plus k. So based on that, h, which would be the x-coordinate of the vertex, is going to be negative 4, and k is going to be negative 18. So the coordinate pair is negative 4, comma 18, negative 18. So that's the coordinates of the vertex. And then the x value, the x-coordinate of the vertex is also the axis of symmetry. So the axis of symmetry is x equals negative 4. So we're going to plot that line. We'll plot this point. The y-intercept, that's when x equals 0, so it's the point 0, comma negative 2. So we'll plot that point. And then these two x-intercepts, those are when y equals 0. So you get 0.24, comma 0, and you get negative 8.24, comma 0. So we'll plot those, and with all that information, we should have a pretty good idea of what we're doing. So I need a piece of graph paper. And I'm going to change the scale because of I need to go from negative 20 to positive 20. So this will be negative 20x, this will be positive 20, this will be positive 20y, and that'll be negative 20. So each grid mark is 2 units. So let's go ahead and plot these. So the x-intercepts are 0.24, which is really close to 0 here. So it's just slightly to the right. And then you have negative 8.24. So this 2, 4, 6, 8, 8.24. So those are my x-intercepts. My y-intercept is 0, negative 2, which would be right there. Again, 2, 4, 6. So that's negative 2. The vertex is negative 4, negative 18. So that goes right here. So 2, 4, and then you go to 20, back 2. So that's the vertex. Now one other thing you have is this green point is going to be right there. So that's the y-intercept, but because of symmetry, you actually have that point. And now we can draw a reasonably good sketch. So it's going to go like that, and then it's going to go up through this y-intercept and then continue on up. So it's pretty steep at that point. And you can do the same thing on the other side. The only thing we didn't plot, which I need to do, is your axis of symmetry. So the axis of symmetry is this line, x equals negative 4. Okay. So that's how it works. Okay, second thing is a third order polynomial. And I'm going to pause for just a second to come up with a problem, make up a problem. Okay, so I'm going to give you a third order equation. So we get x cubed plus 5x squared minus 4x minus 20. And I'll give you one of the zeros. So I'm going to say one of the zeros is x equals 2. So then it says find the other zeros. So what we have in this case is this is the 0, but what we would have is x minus 2. The factor would be x minus 2 to go with that 0. And then you're going to have some quadratic expression. To get this quadratic expression, we can use synthetic or long division to solve for what this divided by that by this factor is. So this divided by that factor is the remainder, is this leftover bit, not a remainder, but that's the. So what we can do is let's use synthetic division. So you put the coefficients of the original expression, which are 1, 5, negative 4, and negative 20. Because I said this was a solution to this, I know it's going to come with a 0 remainder. And remember, the number you put here is not the factor, not negative 2, but the 0, which is 2. Okay, so we bring the 1 down. 2 times 1 is 2. 5 plus 2 is 7. 2 times 7 is 14. Add these together, you get 10. 2 times 10 is 20. Add these together, you get 0. Okay, so what that means is what I've got left is 1x squared plus 7x plus 10. So now you see if you can factor this. And the one I'll give you, you can factor. There'll be three factors and 3 zeros. So this one you should be able to do by observation. What two numbers multiplied together give us 10, whose sum is 7? Well, the answer would be 5 and 2. And because this is positive, these both would be positive. So our factors are these three. The zeros, which are also the x-intercepts, are going to be x equals 2, because I gave you that, x equals negative 2, and x equals negative 5. So those are the zeros. Those are the x-intercepts. Then if you do the y-intercept, that's when you set x equal to 0, and you can put that in here, and you can see it's going to be y equals negative 20. So that's the y-intercept. And the leading coefficient test tells me that it's going to look something like this. It's going to start at negative infinity, go to positive infinity. If this were negative x cubed, then it would go the other direction, so that you can use the leading coefficient to know which way you come from. And we're going to probably need one other point, at least one other point. So let's evaluate the function at some value between here and here, which actually we already have one of those because x equals 0 is between these two. So let's pick another one. Let's pick 3.5. So we'll pick x equals 3.5, negative 3.5, to find the y value. So we got one that's halfway between these two, and we pick one that's halfway between those two. So we're going to evaluate the function at negative 3.5. So it's just a matter of taking the original equation and plugging the numbers. Okay, so you try that out, see if you can get the same answer I do. So we get negative 3.5 to the third power plus 5 times negative 3.5 squared minus 4 times negative 3.5 minus 20. So I get 12.4 approximately. It's 12.375. Okay. So here I've got the point negative 3.5 comma 12.375. Down here I've got the 0 comma negative 20. And I've got these three x-intercepts, so now we should be able to do a pretty good job of plotting this thing. Again, I'm going to change the scale. Instead of being 1 unit for each grid, it'll be 2 units, so this will be 20. This will be minus 20. This will be negative 20. This will be 20. So let's do the x-intercepts in terms of the red color. So it's negative 5, negative 2, and 2. So it's negative 5, negative 2, and 2. Those are my x-intercepts. My y-intercept, which is along the y-axis, is negative 20. So we'll do that in green, negative 20. And at 3.5, which is right in the middle of these two, you get 12.375. So this is 2, 4, 6, 8, 10, 12, 12.375. So finally we can draw a sketch, and so it comes up this way because of the leading coefficient, and then it goes up to this value, and this may be not exactly the maximum, but it's going to be pretty close because it's in between. This one goes down, goes all the way down to negative 20. Again, it's maybe not exactly that may not be exactly the point, but it's going to be close. And then this goes up like that, and then it continues up and to the right very quickly. Okay, so that's what it looks like. So again, what you have to do is, if I give you an equation with one of the zeros, you're going to use that with either long division or synthetic division to figure out what the remaining term is. Once you divide this by that, you get that. I'll make it so that this one is factorable by observation. You get the 3 x-intercepts. Now, if this were something that you couldn't factor, if you had complex numbers, then you'd only have 1 x-intercept. And I chose one additional, well, this is my y-intercept, which I set x equal to 0, so those 3 terms go to 0. And that's the y-intercept, and then I picked one other point between these two values of x to get another y value to see how high it goes up, at least approximately how high it goes up. Okay. Now I'll specifically ask for you to do long division. So I'm going to just make this up. So I have 3x to the 4th minus 5x cubed plus 4x minus 10, all divided by x plus 2. Okay, so you set this up, and I've specifically left out one of the elements. You got to remember, you got to kind of do an inventory. You see I've got x to the 4th, x cubed, x squared. I don't have any x squared, so I need to put 0 in there. So when I fill this out, I'm going to have 3x to the 4th minus 5x cubed plus 0x squared plus 4x minus 10. I'm dividing by x plus 2. So we've asked the question, what do I need to multiply x by to get 3x to the 4th? Well, the answer is 3x cubed. So take 3x cubed times x, which is 3x to the 4th. 3x cubed times 2 is plus 6x cubed. And remember, I'm subtracting this so that these go to 0, so I have to do the same thing with the second part. So I have negative 5 minus, because I have a negative times a positive, so this is negative 5 minus 6, which is negative 11. So I have negative 11x cubed plus 0x squared. I just carry 2 because I have 2 terms here. Okay, What do I need to multiply x by to get negative 11x cubed? Well, the answer is negative 11x squared. So multiply that out, I'll get negative 11x cubed, and then I'll multiply the second by the second number. So I'll get 2 times negative 11, which is negative 22x squared. Again, I'm subtracting this whole thing. So this goes to 0. This negative times the negative is a positive, so I'm actually going to end up with positive 22x squared. Okay, bring down the 4, so I get 4x. What do I need to multiply x by to get 22x squared? The answer is 22x. So I get 22x. 22x times x is 22x squared. And then I have 22x times 2, which is 44. So I get plus 44x. Again, I'm subtracting this. So here I get 0. Again, all the times I get 0. And then I have 4 minus 44, which is going to be negative 40x. And then I bring down the last term, which is negative 10. So the question is, what do I need to multiply x by to get negative 40x? Well, the answer is negative 40. So negative 40 times x is negative 40x. Negative 40 times 2 is negative 80. But again, I'm subtracting here. So that goes to 0. So you have negative 10. Negative times the negative is a positive. So it's negative 10 plus 80, which is positive 70. So that's my remainder. So what I can do, that this original equation can be rewritten as 3x cubed minus 11x squared plus 22x minus 40 plus x, pardon me, 40x minus 40x minus 10 divided by, oh wait a second, my remainder was 70. I knew something was wrong. Okay, so let's fix that. Minus 40. And then my remainder was 70, so that's plus 70 divided by x plus 2. Another thing we could say is that f of negative 2 is equal to 70. Now why is that? Well, this is the factor, x minus 2, but the 0 would be x equals negative 2. So I think that only works if this is a linear factor, x plus or minus something. So let's just double check, see if that really works or not. So if we plug it into the original equation, you'll have 3 times negative 2 squared minus 5 times negative 2 cubed plus 0, we're not going to include that, plus 4 times negative 2 minus 10. So you've got negative 2, that's to the 4th. So negative 2 to the 4th is 16. 16 times 3 is 48. So you have 48. Here you have negative 2 cubed, which is negative 8 times negative 5, so that's going to be positive 40. Then you get negative 8 minus 10. So you get 88. Minus 8 is 80. Minus 10 is 70. So that does work out right. Okay. As far as complex numbers, I'm not asking a huge amount. I'm going to give you a quotient, and I want you to put it in standard form. So let's say you have 6 minus 2i divided by 2 plus 7i. So standard form is where you only have a numerator, you don't have a denominator that's complex. So you multiply by the complex conjugate of the denominator. So the complex conjugate is the same term except you change the imaginary part, change the sign. So if this is positive, it becomes negative. If this is negative, it becomes positive. And then you use FOIL. So in the top, you'll get 6 times 2, which is 12. You'll get negative 4i. Negative 2i times 2 is negative 4i. Then you'll get the outer, which is negative 7 times 6, which is negative 42i. And then the last one will be positive 14, because you have negative 2 times negative 7i squared. And in the denominator, you get 4. 2 times 2 is 4. The middle, the inner and outer cancel out. And then you end up with negative 49i squared. 7 times 7 is 49 with a negative sign. And I times I is I squared. So I squared, though, is negative 1. So I squared becomes negative 1 here. Here I combine these two, 46i. In the denominator I have 4 minus 49 times negative 1. So finally, in the numerator I have 12 minus 14, which is negative 2. So I get negative 2 minus 46i divided by 4 plus 49, which is 53. And that's the answer. So that's how you take a complex number that is a quotient and make it into standard form. Okay, the other one is just to do multiplication, which we have actually already done up here, but just if I had 2 minus 3i times 12 plus 7i, you just use FOIL just like we did over here. So you get 2 times 12, which is 24. Negative 3i times 12 would be negative 36i. 2 times 7i is going to be positive 14i. And then you'll end up with negative 21, because negative 3 times 7, negative 21i squared. So the second and third can be combined, because they both I. So you get negative 36 plus 14 is going to be negative 22i. And then the last term, I squared is negative 1. So you get 24 plus 21, which would be 45 minus 22i. And there is your answer. Okay, so that's the first part. We've done synthetic division before, but I'm going to have a specific synthetic division problem. So let's say we have x cubed plus 7x squared minus 11x plus 10, all divided by x plus 2. So inside the bracket, you put the coefficients of the numerator, which are 1, 7, negative 11, 10. Here, you don't put plus 2. You put the 0, not the factor. So the factor is x plus 2. If you set this equal to 0 and solve for x, you get negative 2. Okay, bring down 1. Negative 2 times 1 is negative 2. 7 plus negative 2 is 5. Negative 2 times 5 is negative 10. Add these together, you get negative 21. Negative 2 times negative 21 is positive 42. Add these together, you get 52. So what that says, if I rewrote this, is I'd have this term, which would be x, 1 times x plus 5 times 1 times x squared plus 5 times x minus 21. And then you'd multiply by x plus 2, by the factor. Actually, divided by x plus 2. So the answer, and I'm sorry, that's wrong. I'm doing that wrong. So let's do it over again. So the answer here is going to be 1 times x squared from here plus 5 times x minus 21, and then we take the remainder, 52, and we divide by the original denominator. So you get that. Also, the other thing is that f of negative 2 is 52. So whatever this is, use here, the value of the function is the remainder. So that's f of this original function here. So that's not actually true. What it should be is f. If I said g of x is the numerator, then what I would say is g of negative 2 is 52. So it's the original thing. So let's just check that out. So g of negative 2 would be equal to negative 2 cubed plus 7 times negative 2 squared, negative 11 times negative 2 plus 10. So negative 2 cubed is negative 8, and that should be squared here, not to the 4th power. So negative 2 squared is positive 4 times 7 is 28. Negative 2 times negative 11 is positive 22, and add 10. So negative 8 plus 28 is 20. 20 plus 22 is 42. 42 plus 10 is 52. So you can see it does work out. I'm going to give you a problem sort of like the first one, but it's using synthetic division. So I'm going to pause it so I can come up with a problem. Okay, so here's a function. F of x equals x cubed plus 7x squared minus 21x minus 27. So let's say I give you that one of the zeros, like before, is negative 1. So what we would do is we could use synthetic division on the original expression. I keep wanting to put a 1 there, but there is no 1. It's just 7 minus 21 minus 27. X equals negative 1. So bring 1 down. Negative 1 times 1 is negative 1. 7 plus negative 1 is 6. Negative 1 times 6 is negative 6. Add those together, you get negative 27. Negative 1 times negative 27 is positive 27. You add those together, you get 0. So I'm going to have this x plus 1 is the factor times some quadratic thing. And that quadratic thing is going to be x squared plus 6x minus 27. So can we factor this second part? Yes. So what two numbers multiplied together give us 27, whose difference is 6. So let's think. 9 times 3 is 27. 9 minus 3 is 6. So it's going to be 9 and 3. And because we have a positive 6 here, we put the positive here and the negative there. So that's the final factored version of the expression, of the original expression. The zeros, or the y-intercept, the x-intercepts, are going to be x equals negative 1, x equals negative 9, and x equals positive 3. Okay, let me pause for just a second again. Okay, so there are two more things. We have to talk about rational functions. And we'll do a fairly simple problem just going to pick one out of the book. I need to include this on the test, but let's just pick one that's not too crazy. So let's do f of x equals x minus 2 divided by x squared plus 5x, actually plus 6x plus 5. So in plotting rational function, you need to know what the zeros are, you need to know what the vertical asymptotes and the horizontal asymptotes are, and any y-intercepts. So let's just factor this first. So you'll have x minus 2, and you can factor the denominators x plus 2 and x plus 3. And actually, that's not what I was looking for. It's x plus 5 and x plus 1. Okay. X plus 5 and x plus 1. That works out. So the zeros, set numerator equal to 0. 0 equals x minus 2, x equals 2. So my 0 is going to be at 2 comma 0. So the y will, this will be 0. The function will be 0 when the numerator is 0, and that happens when x equals 2. Okay. Y-intercept. There you set x equal to 0. So you go back to the original form, not the factored form, and all you have left is y is equal to negative 2/5. Because this goes to 0 in those two terms, so you're just left with the constant part. Okay, then you get vertical asymptote. So the vertical asymptote is where you set the denominator equal to 0, and if it's factored already, then that's easy. It's where the denominator goes to 0, and that makes it undefined. So you'd have x plus 5 is equal to 0 as one solution, x plus 1 equals 0 is the other solution to get either one of these factors equal to 0. So you get x is negative 5. That's the vertical line. That's the equation for the vertical line. Here we have a coordinate that was x comma negative 2/5. So that's a point. The values we calculate down here are actually going to be the vertical asymptotes. And then the horizontal asymptotes, there's the rules, and what you do is you look at the highest order term, which is here x to the first power, and here it's x squared. If this is less than that, if this exponent is less than that, then the asymptote is 0, y equals 0. Now if this were squared, then they'd both be squared, the highest order term, and so you take the ratio to leading coefficients. And if this one is higher than that, then there is no limit. Then you have a slant asymptote. We won't worry about slant asymptotes for this. Okay, so with that, we should be able to make a plot of this function. So let's plot all this thing. So in blue, I'm going to do the x-intercepts, which was only one x-intercept, which is 2. So it's 2 comma 0. And in this case, we'll go from negative 10 to positive 10 because that'll work. Gives a little more accuracy. Okay, so the x-intercept was negative 2, so that's there. Actually, it's x equals 2, sorry, the other side. So move that over there. Okay, so that's the x-intercept. The y-intercept is negative 2/5. Let's put it right there. And the vertical asymptotes are x equals negative 5, which is here, and x equals negative 2, which is here. And the horizontal asymptote is y equals 0. So that's going to go out like this. And I always draw it out away from the last point that I plot. So I'm going to draw it out from here. So because I have single vertical asymptotes, I don't have a repeat root, I know that the function has to go one way and come back the other way. So if it goes to negative infinity, here it comes from positive infinity. So thinking about what's going on here, I know that the function has to go through these two lines. I know it can't go up this way because I'd have to have another x-intercept, which I don't have. So I know this thing has to stay below the x-axis, and when it approaches the asymptote, it has to then curve down like that. Now this is going to go through the x-axis, but then it's has a horizontal asymptote, so it goes a little bit above the x-axis, and then it crosses. It doesn't cross, but it approaches there. If it crosses, then you have another x-intercept, but we don't have that. Okay, something like that. Now, because this intercept goes down here, this one has to come from the other direction. So it's going to come down, but because there are no x-intercepts here, we know that it's going to come down to some point in between these two. Don't know exactly how far, but we'll. And again, because this one is going up to this side of the asymptote, you have to come from the bottom side. And so that'll come up here, and then it'll ultimately go along this axis. So it seems like I might do I may evaluate the function at 2 points. I'm going to evaluate it at negative 3.5, which is right in the middle here, and maybe negative 6. So that's 2 extra points. So let's go back here and let me take this function and bring it with me so that I can evaluate the function at 2 extra places. So I'm going to do f of negative 3.5. So that's negative 3.5 minus 2 divided by negative 3.5 squared plus 6 times negative 3.5 plus 5. So in the numerator I have negative 5.5, and in the denominator, get my calculator, I can figure out where I put it. Well, I know I had it. Let me pause for a second here. Okay, it's underneath my book. So negative 3.5 squared and then I subtract 6 times 3.5, or 6 plus 6 times negative 3.5, and then I add 5, and I get negative 3.75. So negative 5.5 divided by negative 3.75 is 1.47. So that's going to be right. 1.47 is actually right there. So it gets almost down to the x-axis, but not quite. And then I'm going to do f of negative 6. So I'll get negative 6 minus 2 divided by negative 6 squared plus 6 times negative 6 plus 5. So negative 6 minus 2 is negative 8. In the denominator, I have 36 minus 36, so those cancel out. And so I've got 5 left over, so I get negative 8/5, which is, so here's 6, negative 8/5. This is 5/5, 8/5 is going to be right there. So then I can pick out that point, and then I have it like that. And I'm going to open up my graphing utility and just plot this function. So the function was x minus 2 divided by x squared plus 6 plus 5. Okay, so let's see what this thing looks like. X minus 2 divided by x squared plus, I've already forgotten again, 6x plus 5. Okay, so we graph this thing out, and there you go. So you see the minimum is actually at about right here. And then this -6 point is right there. And you can see how it comes up, goes through the y-axis, goes through the x-axis, and then very slightly goes above the x-axis. If I zoom in the y direction, you can see how it does come up, but it doesn't come up very much. So yeah, rational functions are a little tricky. But you should be able to at least get all this information. As far as plotting it exactly right, that may take a little more insight than we have a chance to do, but at least you can plot all these things and then give it your best. Think about these things, you know, that don't have it cross the x-axis if there's no x-intercept. Maybe pick a few points, or I'll tell you to pick a few points. And the final one is partial fractions, but I'm going to give you an easy one to do. And the whole idea behind partial fractions is to take a expression that's a rational function and make it into two simpler rational functions. So let's say I have this. So how do I plot that? I could do it as a rational function, but I'm not worried about plotting it here. I'm just trying to break it up into two linear parts. So it's not for plotting purposes. So what you have is you take the denominator and you factor it if it's possible. If you can't factor it, then you can't use partial fractions. So I'm going to have x plus 4 and x plus 1. You see that if you multiply that out, you get that. So once you've factored it, then you say, okay, what I want to do is I want to write it as a function of two fractions that involve the separate factors. So I have a over x plus 4, which I have to figure out what a is to make it work, and b over x plus 1. That's the two factors. Okay, so then you cross multiply. So if you take a times x plus 1, you get that. And then you'll take b times x plus 4. That times that. And then the denominator is just the product of the two denominators. So you basically separate it apart, and then you put them back together. Now these have the same denominator. So to make this thing work, all we have to do is make sure the two numerators are equal to each other. And we have to figure out what the values of a and b need to be to make that happen. So when you're dealing with linear factors, you choose x to be the two numbers that make each one of those subsequently go to 0. So to make this term in the parentheses be 0, x has to be -1. And to make this one go to 0, you let x equals -4. Then you plug that in, each of these into the original equation. So you get 2 from here times -1 x plus 2 is equal to a times x. So you have to plug x in. And actually we're going to change that slightly because it turns out it'll make a equal. I just happened to made a equal to 0, or b equal to 0, which I didn't want to happen. So I'm going to change that to 1, so it will work out something other than that. Okay. So now I've just corrected all those, updated them. Okay. So the choices of these two will only depend on what's on the right-hand side. Okay. So now I plug -1 into here, so I get -1 plus 1, and then I have the second term, which is b, -1 plus 4. Well, this goes to 0. -1 plus 1 is 0. This still has to change to 1. I hadn't done that yet to match that. So here you get -2 plus 1, that's -1, is equal to b times 3. -1 plus 4 is 3. So you divide both sides by 3, and you get -1/3. And then you do the same thing with x equals -4. So you get 2 times -4 plus 1 is equal to a times -4 plus 1 plus b times -4 plus 4. Well, that's 0. So what we're left with is -4 times 2, which is -8, plus 1, which is -7, is equal to 8 times -3. So we divide both sides by -3. So you get -7 divided by -3, which is 7/3. So that's a. So what that means is you take those two values, and remember what we did is we had a over x plus 4, I guess. Yep. A over x plus 4 plus b over x plus 1. So here we get 7/3 times 1 over x plus 4, and b was -1/3, so you have -1/3 times 1 over x plus 1. So this expression is equivalent to the original one. And so anything we do with this, we can do with that. And in calculus, we can solve the problems in this form, but we can't solve them in that form. That's the whole idea. But if you take calculus, we'll go through all the more complicated scenarios. But for right now, I just want you to be able to do the simplest case. So that's it.